Everyone. Welcome to our project presentation on Smart Egg Incubator using ESP32. This project is developed as part of the Information and Communication Technology course. Our group members are Sadul Latif and Hamza Tariq. So let's begin. Here, introduction to Smart Incubation. Here we have first point, precise temperature and control. Egg incubation requires very precise environmental control for successful embryo development. And the second point is overheating risk. Temperature and humidity must be maintained within a very narrow range. Even small variation can affect the hatching process. And the third point, we have automated regulation. Our project focuses on building a smart and automated incubation system that ensures these conditions are continuously monitored and controlled. Now, next slide we have project objectives, and here we have point 1, optimal hatching conditions that will maintain ideal temperature for successful egg hatching. And second point, we have automated thermal management that will implement automatic heating and active cooling mechanism. And third one, overheating prevention. So there we utilize active cooling to safeguard against critical temperature spikes. And fourth one, remote monitoring via IoT. Here we use Blink IoT, where we can see our real-time data that will be enable real-time tracking and control from a distance. Now second slide we have system architecture overview. Here we have 2 points, control layer, where we use ESP32 microcontroller for processing and control, and second, actuation layer, where heater, that we use bulb for heat the egg, and cooling fan for maintain the temperature of incubator. So bulb and cooling fan uh, will be attached with relay that will control the entire system. Now we have next slide that based on dual threshold control logic. To maintain a stable environment, we use a dual threshold control logic. When the temperature is below 37 degrees Celsius, the heater bulb turns on and the cooling fan remains off to raise the temperature. When the temperature is between 37 to 37.8 Celsius, the system is stable and both the heater and fan remain off. When the temperature rises above 37.8 degrees Celsius, the heater turn off and the cooling fan turn on to prevent overheating. This logic ensures safe and precise temperature regulation. Now we have next slide that depends on key hardware components, where we use ESP32 that act as a brain of the system, handling sensors and data and control logic. And the second, we use DH, DHT11 sensor that will measure temperature and humidity. And third one, we use relay. That relay is a module that allows the lower power ESP32 to safely control high power devices. And the fourth one, we use bulb that provide necessary heat for incubation. And for fifth one, we use DC fan that will control the temperature of incubator. Now these slides will be for bills of materials and materials that we use ESP32 that that cost 1150 pkr, and second one DHT11 sensor that cost 250, and relay module that cost 150, and bulb 100, and DC fans that cost 200, and battery 120. And that will be affordable solution for smart incubation. And listing the cost effective component used. Now next slide, that is software and algorithm design. Here we have first point non-blocking code. The software is designed using a non-blocking approach, ensuring continuous monitoring without delays. And second, sensor monitoring, mm, that the ESP on the ESP sorry, the ESP32 continuously read data from the DHT11 sensor. This data is then processed in real time. And third, threshold based on decisions that will actuate heating or cooling based on predefined temperature threshold. And second slide we have Blink IoT integration, real-time monitoring. To enhance usability, we integrated Blink IoT into our system. Blink allows real-time monitoring of temperature and humidity through a mobile or web dashboard. Users can remotely control the heaters and fan from anywhere. Custom dashboard make interaction simple, and the alert system notifies user if conditions become unsafe. This integration adds smart IoT functionality to our incubator. Now it's our block diagram where power supply we use that will supply that will supply power to our ESP32. Then we connect heat bulb with ESP directly, and we then use relay that will further connect with temperature sensor and the fan. And it's our working video of our project. That that is our prototype. Not here you can see we use relay that connect with fan, and we use bulb here. if the temperature if the temperature if the temperature reaches 38.5 Celsius, then the fan is turns on. Now next slide, performance evaluation. During testing, we artificially increase the temperature inside the incubator. As soon as the temperature reached 37.8 degrees Celsius, the system immediately turned off the heater and activated the cooling fan. The temperature was successfully reduced to 37.5 degrees Celsius. That will effective and reliability of the active cooling mechanism. This confirmed that our system can prevent thermal runaway. Thank you for watching our presentation. We hope you found this project informative and useful. If you have any question, feel free to ask in comment section. Thank you.